take it away.
All right. Hi, everybody. And thanks for joining our webinar today called Uncover Common Myths in Biomedical Testing. We're going to go through a couple things today, but before we kick it off, I do want to introduce today's speakers. The first speaker is myself, Michael Raiche. I'm a senior product manager here at Fluke Biomedical. I've managed many of the product lines in the Fluke Biomedical business. Now I've shifted some focus onto the 1QA workflow automation software platform. So excited to be here and excited to share some good content with you. I'm also joined by Elliot Weldon, but I will let him introduce himself. So take it away, Elliot.
Yeah, thanks, Michael. My name is Elliot Weldon. I'm a product specialist in business development for the biomedical products, and I focus mainly on 1QA. So, and that's kind of what we'll be talking about today. So, thank you for joining.
All right, then I'd like to jump into what we're going to cover today. We're going to touch on some myths, as was in the title. We're going to touch on some shortcuts as well that might help you work a little bit faster, and also some advantages that you can fold into your preventive maintenance program. At the end, we're going to watch how we put some of those into practice, both from a customer example, but Elliot's also going to walk us through a real world example as well. So let's just jump right in. First myth we want to touch on is one that comes up a few times, but you can simply put on a purple latex glove to test darker skin tones. I think this is a good myth to start on, but there's a lot more to it than just the purple glove. Should you be using your finger in the first place is one question that comes up. Think about whether your finger is the same as another tech's finger. One of the questions that comes up to me is, should I be using a functional tester instead, even though it says to do X, Y, or Z in the service manual? Like I said, there is some depth to this one, so I want to dig in with a few extra slides here. And the first is how a Fluke Biomedical SpO2 functional tester works, right? At the end of the day, they pretend to be a finger. You can see here on the left how light would normally flow straight through a human finger. And these functional testers, although they're not simulating a finger, they fool the SpO2 monitor into thinking that it is monitoring an actual finger. So they take light from the pulse oximeter, they run it against an R curve inside the device, and then they emit the right amount of light to the detector. The tester has two light detectors with a filter over one of them, so it can discern the type of light, right? It's either red or it's infrared. And as the monitor shines light onto the top of the finger of the tester, red and infrared light, both in succession, the tester will measure the amount of light, will decide whether it's red or infrared, will calculate how much of that light should be shining through the other side of the finger, right, to say simulate 80%. And then it turns its own LED on the bottom so that it looks like it's shining through the finger. So that's kind of how the whole thing operates. This, in the background, it's also running heartbeat pulses, right, to approximate the shape of an arterial pulse. So that varies according to the current amplitude of the pulse. So it's not just a finger simulator, right? It really does a lot more. On the next slide, we're going to talk about why it's not just, why not use your finger, right? Your finger can test only for the state of your finger, right? Which you don't know. You don't know what skin tone you have, right? You don't know what thickness your finger falls into. But a typical healthy patient has a very stable SpO2 in the mid to high 90s. What if you're at 98 one day and 94 another? How can you ensure the consistency of that test? So what a functional tester does is it allows you to vary the settings across a wide range of physiological settings that you can't do with a finger. So, that's one thing to consider. I want to break through a couple of these in some other slides, but I do want to call out the fact that all these things are editable, so to say, with a functional tester and not with your finger. So the first one is transmission level. This is the percentage of total light that's transmitted through the finger. The available settings are dark, thick finger, medium finger, light, thin finger, and neonatal foot. And again, your finger can't do that. The SpO2 monitor has to account for all types of fingers. So it has to make sure that it's working for all types of patients. Patients are being diagnosed and monitored using these pulse oximeters, so it's really critical that these readings are correct. Pulse amplitude on the next slide is also called perfusion, and that's the amount of arterial blood delivered to the finger in each heartbeat. People confuse these two terms, but they mean exactly the same thing. During a heart pulse, right, the less light overall will be transmitted because of the additional blood in the finger. So that's why this is important to simulate. And that's not something that you can do with your finger. So this setting really tests how well the monitor works in a situation when the patient isn't pumping very much blood. Ambient light artifact is the next one. And it's extra light that could be in the patient's environment that could interfere with the SpO2 monitoring. Settings are outdoor sunlight and indoor light of various frequencies that you might encounter. But fluorescent lighting is the closest in wavelength to the red and infrared light that we talked about in that first slide. The amplitude of the extra light can be set to up to 5 times the amount of that transmitted light. And again, this monitor, the SpO2 monitor, should be able to work even with the extra light in the area. And the last one is the respiration artifact, right? This is where patient breathing can affect the SpO2 pulse. So similarly to how the patient breathing can affect blood pressure, it can change the pulse amplitude during each breath. During maximum inhalation, there's pressure on the chest that can reduce the blood pumped for each heartbeat. And the SpO2 monitor should reject that effect of respiration and give stable readings. Can you do that with your finger? But in general, that's a quick walkthrough of why it's not just the purple latex glove. It's the use of the finger in general that we should call into question, and think about what your finger can and can't do and why a functional tester might be the better way to go. But enough on that, let's move on. The next up is a poll question. Elliot, you want to take us through that?
Sure. So we have a question here today. Do you believe that everyone in your facility adheres to the same testing procedures? Just a few answers here, yes, no, or maybe.
Thanks, Elliot.
Yep.
Yep, that poll question has been launched. And let's give participants about 30 seconds to enter their reply. Thanks everyone again for your participation in today's webinar and also in our poll questions.
And no wrong answers here, right? It's a belief question. So just want to see where you guys think you stand.
Okay, wonderful. And let's see, responses continue to come in. And let's go ahead and close the poll because I know we have a lot of additional topics that we would like to talk about. So I'm going to go ahead and close the poll and share the results. So let's see, 36% indicated yes, 47% indicated no, and 17% of the audience indicated maybe. Interesting.
Yeah,
that is interesting.
Yeah, that's
Elliot,
interesting.
what are your thoughts?
Well, I know that, having worked in a lot of biomed shops with biomeds and even having been a biomed before, it's difficult sometimes to standardize the workflows because you have technicians that have been working for a long time, sometimes interns or like newer biomeds, and sometimes there's updates that come out directly from maybe the OEM, or maybe your facility is working on AEM, using AEM procedures, and when changes are made, sometimes half the shop might get the updates, or there's part of the shop that just doesn't want to follow them. They still want to use that 15-year-old procedure that they've been using for forever. So yeah, it's definitely a challenge, I think, across the board for most organizations.
No, absolutely. I think it's really shocking to see the no's and the maybes and just how high those are, right? There's fairly low confidence that you are using the same procedure across the organization. So it's good. It's good that you guys are either feel that or are aware of that. But great segue into the next myth, number 2, if we want to switch to that slide. because I think most facilities, most people, most bosses believe that they are following the same steps. But the truth is you probably aren't, right? Some people make their connections differently. Some people document differently. Some people don't do all the steps. Elliot, you had an example about this at a major customer of ours.
Yeah, it was a few months ago when we visited a customer, and they had two types of workflows. They had bench techs, and they had a field service team, and there was a certain step towards the end of the repair that they were supposed to do in both parts, at the bench and in the field. And after kind of going over the procedures, they found out, because they weren't really using a tool for standardization, that they thought they kind of found out that the field team and the bench techs weren't actually following the same procedure. And for OEM type of work, that's real important to follow. A lot of regulatory groups that look at that. So it's just something that's common, and it happens. And I guess the best thing we can do is just try to mitigate that.
Yeah, and how long did it take you to figure that out? Is that all in the course of the same day?
Yeah, no, when we arrived on site, they had kind of shown us the procedure that they thought they were using. And it was different than the one they had sent me, a few weeks before. So they're like, you built us the wrong procedure. And I'm like, I don't think so. They didn't know exactly what workflows that they were using or what they were supposed to be using. And we were able to get it sorted out pretty quick, but it was definitely an eye opener to us and to the customer.
I bet, yeah. And I mean, what would happen if we visited, any of your facilities for you on the webinar today? We'd love to visit you all and perform that audit ourselves. But we just want to hit on the fact that everybody thinks that they do the same steps, or that they do all the steps all the time the same way. But if you do all the steps the same way, you're going to get results that you can trust, right? You're going to get results that you can track and get predictive on, and really results that you can stand behind. So I think it really is important that we harp on this standardization of the procedures here. But I hope it does give you something to reconsider when you get back to work, especially those of you that said yes. Maybe there's a question in your mind now that since most people said that they don't. But just know that it can really make a big difference. So we wanted to make sure we called that out as a myth. The next one, number 3, actually comes to our tech services team quite a bit. So I really do think it's a good one to cover, because can you really measure the accuracy of an IBP, right? There is a dynamic simulation, but what does that dynamic simulation actually test for? I'm going to go into that in a little bit more depth on the next couple of slides. So first, I just want to cover blood pressure measurement in general. NIBP, non-invasive blood pressure, can be tested using static pressure, right? So this could be, pressure generated by a bulb and measured by a pressure meter, or using an automated patient simulator. And the other way you could do it is dynamically, right? So you can use a simulation using an NIBP patient simulator. So there are 2 different types, static and dynamic. Typically, the specific accuracy has only been assessed by the use of static pressure measurements. These measurements are very straightforward, very easy to understand, but the NIBP of a patient isn't static. So dynamic accuracy, right, which is more closely related to the patient itself, is really hard to nail down. So OEMs have done this using statistical sampling and the analysis of clinical measurements, but there really is no standard in terms of how to assess dynamic blood pressure, right? Especially in terms of accuracy and repeatability. So patient simulators have really been used in the past to mimic that dynamic nature of NIBP, because it is quite repeatable, but it might not be clinically correct or precisely clinically correct. Let's put it that way, when you compare it with a live patient. So there's a mix between qualitative and quantitative analysis here, but it is assumed that if NIBP is the NIBP measured and displayed on the patient monitor, if that matches the pulse rate, systolic, diastolic, and MAP numerics, if these all fall within the accuracy range specified by the patient monitor, then the performance has to be acceptable. For this reason, that's why we look for groups of patient simulator settings, right? So we look at healthy, we look at diseased, those different states, and see how it affects performance testing. This simulator, it is a simulator. It's not a live patient. So it is an inexact science, but it is possible to measure the repeatability of these simulations. So without delving too far into that, the next slide just kind of will compare accuracy and repeatability. I'm not going to read all of this here, but the International Organization of Legal Metrology's recommendation on non-invasive automated sphygmomanometers describes an NIBP patient simulator as, quote, not used for testing accuracy, but is required in assessing the stability of performance of NIBP patient monitors. So we have a number of webinars on NIBP where you can learn more on measuring repeatability and how you can use the envelope shifts to do so. But I won't really get into that today, but I want you to know the main takeaway is static pressure, right, is going to be used for accuracy, and you're going to use the dynamic simulation for repeatability. It comes in time and time again from tech services, but there really is no way to measure dynamic simulation accuracy. So a lot there. It is meaty. There's a lot behind it, but that's what I want you to take away from that. All right, and the last myth is one that's also raised to us quite a bit. But AEMs, or alternative equipment maintenance procedures, right, are increasingly being used, and that's fine, right? They should be based on data that can be pointed to in terms of why that test or why those test points are being skipped or reduced. But I do want to plant a seed of doubt, or at least be contrarian and say, maybe it shouldn't ever be done. I think skipping electrical safety testing, we need to call that into question and just think about, okay, what are you trying to do when you do electrical safety testing? The medical device, you want that to be safe for a patient to be connected to, and we want the medical device to be safe for a clinician to operate. That's kind of the basis behind the whole thing. And electrical safety testing is valid for a point in time, the point at which you ran the test, and it's likely to remain safe for a period of time. But think about what that medical device goes through on a day-to-day basis, right? Is the medical device wheeled over bumps? Is it dropped or tipped over? Does it ever experience environmental conditions that it shouldn't? So think about humidity or temperature. And then even on incoming inspection, right? When a medical device, a new one, arrives at your hospital, do you do an incoming inspection to make sure that it wasn't damaged during shipping? Or are you trusting that it maintained the manufacturer's specification from the factory to your facility? Elliot, any other examples that you might want to throw out there?
Yeah, even with initial inspections of maybe equipment that comes into the OR for cases that are being done, with the local OEM reps, it's important to go and electrical safety that equipment. Just because maybe they grabbed a power cord that they found in a bin somewhere in the hospital, and that power cord was supposed to be thrown out, right? And that the reason why it's supposed to be thrown out is because it was with electrical safety testing determined that power cord was making the product fail, basic electrical safety, or just products in general or devices in the hospital. Sometimes those power cords get corroded or old or bent or cut open, and they need to be checked, and that needs to be rectified as soon as possible.
And I'd throw out the question of how do you determine that a cable needs to be thrown out or replaced, right? You can't really determine that if you're not doing electrical safety testing, at least for the applicable cables that would be plugged in. So again, it is a way to see if that cable that's been run over a million times is still working, right? You can't do that without electrical safety testing. But I guess our point is that there's just a lot of things that can happen over the course of a year, if that's the period over which you're repeating your electrical safety testing. But if you extend that out, right, say you want to do 3 years or 5 years or even longer, how are you sure that your product remains electrically safe for both patients and operators? I always like the example of hooking my mother up to the medical device, right? Think about if you would do that after 10 years of not doing electrical safety testing. How would you feel about that? So just some food for thought, but I would be a little contrarian and say, hey, maybe we shouldn't just throw electrical safety out the door. There's definitely some value there. All right, so with that, we're going to move over to some shortcuts. So who out there wants to make their defibrillator procedures, or at least the execution of them, easier, right? One thing that I want to point out is that the ESA 612, 614, and 615, all of those devices can actually be used to expedite the testing of your defibrillator. Say you've done your testing on your Impulse 7000, you've done your discharge tests, take your quick connectors, right, and connect it right to the top of your ESA. There are 5 ports at the top, right? And then you'll take some adapters, right? These are the snap to banana pin adapters. They're actually part number 2462070. If you're curious to go after this afterwards, but put those in the other 3 ports. So you have all 5 filled, and then you're going to hook up your 3-lead ECG. And then you have your hands-free adapter in the other 2 ports. You can plug in your defibrillator to your ESA, right? You can run your ground wire resistance, your ground wire leakage. All of that's kind of the same. And in these 2 thumbnails here, you'll see Justin Ross. He has 2 great videos to walk through this. He goes into much more detail than I will here. But applied parts is really where the magic happens. You can group the applied ports together to separate your ECG leads and then your hands-free adapter. And you can test the leakage for each group separately. So think about it. You've moved one connection right from Impulse to electrical safety. You're moving your ECG leads over. It's a really easy move from one device to the next, and a good way to save time. So you're connecting your entire defib at one time, and you're allowing it to do all the testing that you need, whether you're on your Impulse or on your ESA. And you might ask, hey, that's a good example for 5-lead, but what 3-lead? But what about 5-lead or 12-lead? How do I do that? That's what's circled here over in the blue circle, and that's our 12 or 1 to 10 adapter, right? And there you can group all of your leads together, whether it's 5 leads or 12 leads, and follow basically the same procedure. So again, it's one setup, it's a few button pushes, and it's a seamless switch from Impulse testing to ESA testing. So do think about investing in those small accessories, right? The snap to banana pin adapters and the 1 to 10 adapter. It can really help expedite that procedure for you. The second one is tied a little bit to an earlier myth, but it's still a shortcut that I'd really like to hit on, which is, do you use the same procedure in your facility, right? We called that into question. We saw that no's and maybes were really high. But a great shortcut that I want to share is to actually do that. Actually standardize the procedures across your organization, right? Start with a really good procedure, roll it out across your organization, and make sure that it's being used. And the next few slides will show you what makes up a good procedure. And the first thing is picking the right procedure, right? The best practice is to pick that procedure, right? Record your results of that procedure, track your results, but it really starts with the actual steps itself. It should follow the OEM service manual, right? And if it doesn't do that, then it should track to your local, national, or international standards, right? This ensures that your testing is complete and compliant. And the best way is to lock in that procedure to make sure everyone's using it. Best practice is to use a workflow automation software, but even if you're using the same pen and paper procedure across the organization, just make sure everyone's following the same steps. And yeah, the next step is to follow it, right? Make sure that all the steps are carried out. Make sure that all the results are taken and are documented. And if you're doing so, track any trends. It's really critical not only to have a process, but to follow it. And then consider some other things. We talked about AEMs earlier, right? If you are using one, who's making sure that that procedure is compliant if you've adopted an AEM? Who's making sure that those omissions are backed up by defensible data? Just ask some questions there. And you know, if you're asking, or if you're testing with pass-fail and not actually taking down results, ask your organization, ask yourself, is that enough, right? Should you be taking down values? These are all parts of your procedure in terms of steps to be followed. The next step is version control, right? In addition to having a procedure that's compliant, you want to make sure that you don't change that procedure very often. So stick with a common procedure, but if you do change, right, document what was changed and why. You want people to be able to look back, and you want to be able to defend your decisions. And additionally, you know, any changes should be managed by an administrator for your whole organization. This should push out all changes across your org, right, and into all of the systems. So going back to Elliot's example, make sure it gets to every single group. And this makes sure that the whole team is always using the same procedure all the time. You should feel confident in that. The other part of a good procedure is how often you're going to run that procedure. So you have to determine a test frequency. This should be in your service manual, but if it's not, right, you should take a risk-based approach, which is here on the right side of this slide. So this takes into consideration the criticality of the medical device, the risk that a failure might have to the facility, the probability that a failure could occur in your hospital's experience, and also the industry's experience with that medical device. If you take all of those things into consideration, that can also produce you know, a risk-based assessment of how often you should be testing that medical device. So do know that there are options out there if the service manual doesn't provide anything to you. And the other part is make sure that your test is comprehensive. You want to make sure that you do one test that covers the whole medical device or asset. So on this slide, we have the example of an anesthesia delivery system. It has a patient monitor, has a ventilator, has a vaporizer, and it runs off mains power. So to do the testing, you need a number of medical devices. You need a gas flow analyzer, you need a multi-gas analyzer, you need an electrical safety analyzer, you need a patient simulator, and you know, the list of tools doesn't just involve that. There's probably some accessories and PM kits and things like that that need to be called out as well. So most medical devices are always doing safety and performance, right? So you always need an electrical safety analyzer and some sort of performance analyzer or simulator. So our advice, make sure that you do it all at one time and link the results back to that asset number. That way you have one comprehensive test tying back to that asset. And the last thing is just make sure that you have everything you need at your fingertips, right? Every time. It's not just the procedure, right? It's not just the tools, but can you call out where the device is, right? What room, what wing, any codes that people might need in order to enter into a service mode, for example, any training that a technician might need if the task is infrequent, any pictures of how connections should be made, and really make sure that you have a secure place to record your results. You know, paper's fine, but you want to make sure that you're trying to do it once and do it without the need to re-record or repeat steps. You really want to reduce any trips back to the shop. You want to make sure that you're not having to look on the internet, that you're not having to make phone calls to figure out how to do something. This is all frustrating. This all increases the time to test, and really it's preventable, right? If you make sure it's built into your procedure. So do make sure that all of those things work into your procedure as you standardize it across your organization. So with that, we're going to move on to another poll question. So Ellie, you want to take it away?
Yeah, here's the question that we have is, when considering a change in your procedure process that may save you time, do you consider the potential risk involved?
Thanks,
We'll go with-
Elliot.
Yep.
That poll question has been launched. And we will give participants about 30 seconds to enter their reply. And responses are coming in.
Yeah, risk is a funny thing. Different people deal with it in different ways.
Absolutely. Okay, Mike and Elliot, I'm going to go ahead and close the poll question. And I'll share the results. So let's see, 94% of the audience said yes, 22% said no, and the additional 4% said maybe.
No, that's great. I mean, I think risk is a tricky thing, right? But I think if you don't consider it, you're potentially putting yourself at risk of many, many things. So it's good that 94% of you guys are thinking about that, because it is right to consider it and have it guide your decision-making process. But I do want to just move to the next slide there, because this just came out from the FDA, and really it highlighted misconnections. But I did want to bring it to your attention. It's not something that you guys can control, but it is an example that misconnections do happen. And it's really an urge to think about how you can prevent errors in your facility. So if you go back to those standardization slides, right? Are your connections documented? Are your tools documented? Should they be? If it's preventable, prevent it. I think in this case, if I remember correctly, this was this is an airline attached to an IV catheter. So again, it's just something that is preventable. There's a risk here, but you can easily de-risk it by documenting it. So just an interesting example I wanted to bring to everyone's attention that was pretty relevant. But with that, I'm going to move on to the third shortcut. And many of you probably own a ULT 800 to do some TE probe testing. But one thing you might not know is that you can actually use your Fluke Biomedical ESA to do similar testing. The ESA can be used along with, again, another part number here, 3476233, to test conductivity, and then the ULT adapter plates can actually be connected to the ESA as well. And the added benefit here is, compared to the ULT 800, you're going to get a pass-fail. With the ESA, you can actually get the exact leakage readings. So in the second kind of extra usage for the ESA in terms of ultrasound is performing a mains unapplied part test, right? Or a lead isolation test on diagnostic ultrasound transducers. So this testing can be done with the transducer either attached to the ultrasound system or on the transducer itself when it's detached from the system, either for cleaning or disinfection. These are two great applications, and there are two great application notes to go along with this that'll walk you through the step-by-step process in detail. But I did want to point these out to you today. I think they're great references and great ways that you can increase the ROI on your ESA if you already own it, right? So you can stretch that usage. And if you're trying to justify the purchase for one, same thing. You can bring these up as extra use cases for your facility, where you can use it for TE probe testing. So think about these. It might be able to stretch your dollar a little bit more if you own one of these or are planning on owning one of these. The fourth shortcut kind of ties back to that FDA call out and what you shouldn't do. And it's not making a misconnection, it's actually improvising connections. We know that the QAES3 has a lot of connections and that this setup can be confusing, but it's really not that bad if you know what you're doing. One thing I want to point out to make it less confusing is a series of videos that we made to walk through the testing of certain electrosurgical generators. We walk you through test setup, we walk you through connections, and we really let you, walk you through tip to tail how to do that. And these videos can be really helpful in explaining how to perform those tests. So I do urge you to take a look at those if you are confused. But some people ask, why we have all these cables. And each one of these cables performs an individual function. Each one of these cables has to remain separate, and they all have to remain isolated from one another. Fluke Biomedical cables and Fluke Biomedical cables, right, and our products in general are really designed with safety, quality, and accuracy in mind. And that's why we always ask our customers to operate them in a certain way and to use certain accessories. We are dealing with high voltage and high current in this specific application, and it can be potentially damaging. So we're doing this to make sure, we're keeping patients safe, but we're also keeping operators safe. And in this case, the operator is you. And at the end of the day, you can't keep patients safe if you're injured. So do keep that in mind. This is a product safety issue. So try not to improvise connections as much as you can. And I say that a little bit with an asterisk as we jump on to the fifth shortcut, which is improvisations you can make and should make when Fluke Biomedical doesn't provide the cable that you're looking for. If we have the cable, please use it. It's designed for it. But our industry isn't standardized on connections. In those cases, we make an unterminated cable, right? So it has the Fluke Biomedical end for whatever simulator or analyzer you're using. It has open wires on the other end, and all you're going to do is put a connector on the end. So the cable is safe for its use case, right? It connects to the Fluke Biomedical device properly. Really, all you have to do is kind of nominate a sacrificial cable to be cut so that you have the medical device end and that you can connect any one of our cables to the medical device on your own. The product lines most commonly affected by this are ProSim and Impulse. But again, with everything, use common sense, use good electrical safety practices, and you'll be able to test any medical device that's out there. All right, so that brings us to the last poll question.
All right, so the last question we have here is, do you think there is room for improvement in accomplishing your daily responsibilities?
And that last poll question has been launched. And once again, we'll give participants 30 seconds to enter their reply. And I will then close the poll. Mike, Elliot, you ready? And here we go. I'm closing the poll now. Let's see, 91% of the audience said yes, 3% indicated no, and the additional 5% indicated maybe.
I think that, any job in the world, I think, most people would say yes to this. There's always room for improvement. And, having been a biomed before, I know that, a lot of times we'd like to be able to do more. There's only, 8 hours in a day, usually for a work day. And, if we can figure out a way to accomplish our goals earlier or quicker, then, that gives us more room to, maybe grow and get into some of those responsibilities that we've been maybe don't have time for during our day. So just finding quicker and better ways to improve our processes to get the job done.
Yeah, no, I agree. I think it takes a growth mindset, but I'm glad you guys seem to possess it. So with that, yeah, let's hop over to the advantages real quick, and then we'll get you over to Elliot's show and tell. But the first one is using all-in-one analyzers or simulators, right? The question I'd ask is how many tools you do use today to perform your day-to-day testing. Would it be nice to consolidate any of them? Can you consolidate any of them? Is there something on the market? There are some options that can help you do more, right, and carry less. The VT900A is a good example, right? It can replace your flow meter, your oxygen meter, your IDE counter, humidity sensor, thermometer, lots of things. The ProSim, it can replace any standalone NIBP monitors, right? But it also does IBP. It has an ECG simulator, an SpO2 functional tester, all of that in one box, right? Impulse is another one. It combines defib testing, pacemaker testing, and ECG simulation in a single box. Would that help you improve your workflow? Think about calibration. It's not just carrying less, it's calibrating less. So there's no need to deal with multiple vendors when you do that. When you have different functional testers, you have one, right? It goes out for one calibration, it comes back with one report, it comes back with one price. So do let that be a factor in your decision as well. So combining functionality can help you carry less, right? It can help you calibrate less. So if your facility is willing to invest, if your facility does have that growth mindset, these might be great products to look towards, leaning on and making that happen for your organization. So do keep those products in mind and those that I didn't mention as you look towards your next purchases. The other advantage is test automation, right? Have you considered it? It comes in many forms. The simplest one is auto sequences. So this is a series of tests, one after another, and that outputs either data or a pass-fail result. The best example of that, excuse me, that we have is the ProSim 8. You can fire off a few simple tests that you can configure, by the way, to get your testing done and get your testing done quickly. Some people have used it to run a normal, right, a high and a low test to be able to see if your alarms are triggering appropriately. But there's a next step to this, right, which is onboard automation. So this brings ESA 615 to mind. So this device comes pre-configured with some procedures built to international standards that can be run with the push of a button. You have to move an alligator clip a few times, sure. But after that initial test setup and a couple moves, your test is done. This can actually help you test more in less time. A lot of customers use and test these to the higher international standards, even though it's above what their facility requires, because they actually get it done faster. So do think about it. It's a great example to do less with more, right? Or do more quicker. The other ways, there are different ways to think about test automation, which is firing off the steps of your procedure more quickly. New test equipment can help with that. So another two examples of products that do a really good job of that. And the third advantage, and the last one, is to use workflow automation. And I want to hit on some things that might frustrate you in your job, right? Missing a step and having to go back and repeat that procedure, right? Forgetting a tool, an accessory, a cable, and having to walk back to the shop just to get it so you can start testing. The monotony of testing some things. The frustration of forgetting how to do a certain procedure because you only do it once a year. Onboarding the new guy, right? Any interruptions you might get. These are all pain points that we've heard from you where workflow automation can help. Help by calling out a connection so that you don't forget it. Help by calling out a list of accessories so you bring it with you the first time and don't have to go back. Allowing you to stop your procedure midway because you got a nurse call and remembering where to start again. These are all things that workflow automation can help with. And really, I just want to hit on three final slides before I hand it over to Elliot, which is really the value of automation. It really allows you to focus on testing versus all the other stuff, right? It lets you not thoughtlessly, but thoughtfully do your procedure, set up your procedure, keep your place, right? Get your results. There's a lot of value in being able to focus on the task at hand and not everything around it. The other value is saving time, right? You're able to load your procedures. You're able to run those procedures in an automated fashion. You're able to generate those reports automatically and keep them in a single place. Just the fact that you know what task to run and you're able to generate a report automatically, the documentation time savings alone can be astronomical. So do consider taking that next step. And the last one is quality, right? Making sure that you are standardized, right? This is a way to standardize that procedure. It's a way to make sure everyone follows every step. Everyone knows exactly how to do the test. Everybody follows the same procedure, so has the same points, and you have data time over time, and you can track them, right, and be predictive. There's no missteps, there's no typos, there's no compliance risk. When you know that you rolled out the procedure across your organization, you know that you're going to get the same high quality results across your organization. So do think about those aspects, right? Do think about workflow automation, think about onboard automation, think about at a minimum standardizing your procedures. But I hope that gave you all on the phone a bunch of food for thought. But with that, I do want to stop there and toss it over to Dan and Elliot to walk through some real world examples.
Great, thank you, Mike. I'm going to go ahead and throw on this video.
I can have a ticket that comes in, I accept it as a work order, and say it's verifying a bedside monitor. I have at my fingertips, through True Asset, I can add a Fluke 1QA procedure to that work order. And by doing that, I then launch into Fluke 1QA, perform my bedside monitor test. At the end, I claim that it's done and save it. My Fluke 1QA procedure now has been attached to my True Asset work order. And by doing that, I have the best of both worlds.
Through this two software packages, 1QA and True Asset, with the automation pulling in from test equipment, your testing procedures have complete integrity. And to me, it's very important, the integrity part, because I've actually been on the other side as a patient, on the table, in the OR, in a patient room, on an IV pump, with equipment with my initials on it. You never know when somebody you know and love is going to be on the other side of that. And this is a very huge way that we can ensure that everything is done properly and tested and is safe.
All right, Elliot, do you have any comments on that before we move on to the next one?
No, I think, Mount Nittany has really taken advantage of this tool. They're biomeds that, and I think every biomed for the most, does think about this the same way, but they really do think about, the possibility that this equipment that they're working on could be hooked up to them or a family member someday. So they want to make sure that they can do as good of a job as possible to make sure that equipment is taken care of safely. And they do a really good job of explaining that and how they're using the integration and the tools from Fluke to get the job done.
Perfect, thank you, Elliot. Well, let's go ahead and move on to the demo. Go ahead and kick this one off as well.
What I'd like to show now is a demonstration of 1QA using a CMMS platform. Today we're going to demonstrate how easy it is to complete your workflow using True Asset and 1QA. Here in True Asset, we can look for our work order. Today we want to do a basic electrical safety test on a defibrillator. I'll select Perform Procedure. Through the integration built with our Open API, all we have to do is select Fluke 1QA, and we will open Fluke 1QA. Although we're using True Asset in this demonstration, with that open API platform, we can integrate with most CMMS systems, as well as asset management tools and field service tools. So top of the screen here, we have our test activity, the start time and the tester, as well as the date. Our work order ID has been pulled over directly from the CMMS. Asset information is not located right here in 1QA, but once we push the data back, it will the test will be filed within the asset itself and the work order. We have our test device information, and we'll just do a basic electrical safety test. One of the myths in the biomed world is that electrical safety can be skipped, but what you're going to see here is that using 1QA, there's really no reason to skip it. I mean, we're going to save a lot of time. We're going to run this test in 15, 20 seconds. So we'll start off with the physical inspection. Pass, pass. We'll use our NFPA 99 electrical safety standards. Now keep in mind, we're still going to have to connect our devices, our Fluke devices, to the device under the test, so we can add diagrams and pictures into the test. Here we have our applied part set up. We only have a 3-lead ECG on this device that we're testing today, but let's just say that you had more than 5 applied parts, meaning maybe 5 ECG leads and an SpO2 sensor. We can use Fluke Biomedical's 1-to-10 adapter that will allow us to do these tests also with 1QA. So now I've connected all my cables to my device, and I'll just press play. As you can see here, we're doing about 25 measurements, testing all of the ECG leads, as well as earth leakage current and mains voltage. Now that we're done, we'll click completed. That took us roughly 30 seconds to do 20 measurements. Once we get back to true asset, we'll just read the instructions here. After the procedure is complete, close the pop-up. I'm going to close it. And all of our data automatically moved over right into true asset with all of our information. I'm going to want to close the work order. So I'm going to select mark complete, confirm, and I'll close it out. That took us about 5 minutes. Preventative maintenance test, submit. And that was our test using 1QA as workflow automation with the integration of a CMMS system. If there is a need to also have a PDF attached to your CMMS system, we have one here. I'll click view. And I have my report right here.
Great. Thank you so much, Elliot and Mike. That was a really informative session. We appreciate everyone staying for the entire presentation and want to jump right into the Q&A. We've had some good questions come in. The first one is, can we use non-Fluke devices with 1QA?
Yeah, with 1QA, you know, we saw that you can use the ESA 614 or 15, which we showed in that video. We have a lot of other Fluke-enabled devices, but if you're using a different brand, maybe potentially an older brand that Fluke has purchased in the past, you can use that in 1QA. You won't get the automatic data pull from the device, but we can still set up our standardized procedures with limits, just as we did in the video. The only difference is that we'd have to read the results from the analyzer and just type them in. We'll still be able to standardize all your workflows using 1QA.
Okay, great.
Yeah,
Thank you.
Procedure generation and management and report generation, all of that can be used for anything. So really think of 1QA as a tool that you can use for whatever test tool you're using, putting in the results and getting the reports. And if you happen to have a Fluke Biomedical or a piece of Raiche test equipment, you're able to automate that and make it even faster.
Okay, super. Thank you for that. Second question is the complete ultrasound testing using the ESA found on the Knowledge Center link on the Fluke Biomedical website?
Yeah, both of those application notes should be available up on the website. I think, Dan, do you think it's possible that we could throw those into the chat just to make it easy for everyone today?
Yes, let me locate those and I'll do that. Or we could
Great.
send it in a follow-up email with the link
Or that. Yeah.
to this webinar.
Yeah, let's do that, and let's
Super.
collect the other 2 videos as well, and that way people have easy access.
Perfect.
Great idea. Thank you. So with 3 minutes left, we have a couple more questions. What is the expectation of timing for my shop to be up and running?
Is that, I'm assuming, up and running with 1 QA. So typically, you know, we'd like, you know, if you're interested, contact either Fluke Biomedical through the website or your local channel partner, and we'd obviously we'd meet with you, go over a demo, kind of see, you know, where this would fit in your organization. At that point, we could set up trials, or we could move into more of the actual subscription, and we can be up and running. You can be up and running pretty fast. If you are looking for an integration, it might take a little bit longer, but that's just because, you know, we have to make, you know, there'll have to be connections maybe between your CMMS and 1 QA. But we have seen hospitals get up and running in 2 to 3 weeks from, you know, right before purchasing to running with the integration with their CMMS. So it doesn't take too much time.
Okay, and one final question. Can 1 QA be integrated with any CMMS?
Yeah, right now we have current integrations with some of the bigger CMMS systems and asset management tools with the open API platform. We haven't came across one yet that we can't integrate with. So I would just assume that we can. I'm sure there's one or two out there that we can't, but haven't came across that yet. And just contact us and let us know. I think we'll be able to help you out with that.
Yeah, think about it as kind of a group project where, you know, we have the open API, so we're open to working with other people, and they just have to be able to, the CMS provider has to be able to help kind of close some of those loops for us to make that happen.
And there are a few questions we didn't get to, so we'll make sure to follow up with the asker on those after today's webinar. So thanks so much, Mike and Elliot.
No, thank you all for joining. I really appreciate you guys being here.